Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazrin Masbudi. I will explain about the food industry. That I choose is margarine. For introduction, margarine and related products contain a water phase and a fat phase. Can be characterized as water in oil emulsion, in which the water phase is excellently dispersed as droplets in the continuous phase. Depending on the application of the product, the composition of the fat phase and the manufacturing process are selected accordingly. The equipment in margarine production first is GS concentrators as low pressure SSHE or combinator 250 SHCW as high pressure SSHE for pasteurization process. Next is SSHE units from the GS brand, GS Nexus and GS Combinator for chilling and crystallization process. GS Pin rotor machine for kneading process. Then GS Logic Control System is designed to control, record and document important condition and parameter concerning the complete manufacturing process. CIP system for cleaning process. For margarine production process, this is the PNID. The process goes like this. First, the preparation of the water phase and the fat phase. The water phase is often prepared batch-wise in the water phase tank. The water can be subjected to the pre-treatment by a UV or filter system. The various fat and oils, either as fat blend or single oil, are stored in oil storage tanks normally placed outside the production facilities. These are kept at constant storage temperature above the melting point of the fat and under agitation in order to avoid fractionation of the fat and to allow easy handling. The second phase is emulsion preparation. The emulsion is arranged by transferring various oil and fats or fat blends to the emulsion tank. In order to complete the preparation of the fat phase, the emulsifier and other oil-soluble minor ingredients are added to the fat blend. When all the ingredients for the fat phase have been correctly mixed, the water phase is added and the emulsion is created under intensive but controlled mixing. The third phase is pasteurization process. The pasteurization process will guarantee the inhibition of bacterial growth and growth of other microorganisms, hence improving the microbiological stability of the emulsion. The pasteurization of the water phase only is a possibility, but pasteurization of the complete emulsion is ideal since the pasteurization process of the emulsifier of the emulsion will reduce the residence time from a pasteurized product to filling or packing of final product. Then the next phase is chilling, crystallization and kneading process. The emulsion is pumped to the crystallization line by resources of high pressure piston pump. Pin rotor machine and an intermediate crystallizer are regularly included in the line in order to add extra kneading intensity and time for the production of plastic products. The core of the crystallization line is the high pressure SSHE, the GS Nexus, the GS Combinator or the GS Perfector, in which the warm emulsion is supercooled and crystallized on the inner surface of the chilling tube. When the fat in the emulsion crystallizes, the fat crystal form a three-dimensional network entrapping the water droplets and the liquid oil, resulting product with properties of plastic semi-solid nature. Then we will go to next phase, phase, the packing, filling, and remelting process. A resting tube is the final step of the crystallization line, and is only included if the product is packed. It is obvious that a packed product must exhibit a firmer texture than a filled product, and if this texture is not optimal, the product will be diverted to the remelter system, melted and added to the buffer tank for reprocessing. For the automation, traceability demand can be implemented in the control system of the industries, and the Gerstenberg-Schroeder GS Logic control system is designed to control, record, and document important conditions and parameters concerning the complete manufacturing process. When the product leaves the production line in a suitably packed or filled form, it is apart from the product name usually marked with a date, time, and batch identification number for later tracking. The complete history of all the production steps involved in the manufacturing process is then filed for the security of the producer and the end user, the consumer. Then we will go to cleaning in place CIP. CIP plants which use the cleaning media only once, or recommended CIP plants which operate via a buffer solution of the cleaning media, where media such as lye, acid, and disinfectant are returned to the specific CIP storage tank after use. The latter process is ideal since it represents an environmentally friendly solution, and it is economical solution in regard to consumption of cleaning agent and the cost operation. The conclusion is when producing food or non-food product, it is essential to keep in mind that it is not only the ingredient like the oils and fats used for the recipe of the product which can determine the quality of the final product, but also the configuration of the plant, the processing parameters, and the state of the plants. If the line or the equipment is not well maintained, there will be risk if the line is not efficiently performing. Consequently, to produce a high quality product, a well functioning plant is an essential, but the choice of fat blend with characteristics which correspond to the final application of the product is also important, as well as correct configuration and choice of processing parameters for the plant. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. I, Muhammad Alif Aiman bin Syamsul Kamal Bahrain, will present about palm oil production for non-food industry. I choose biodiesel as the product used from palm oil. So our topic today gonna be biodiesel manufactured from palm kernel oil. So let's go. Introduction for biodiesel. Biodiesel is a form of diesel fuel derived from plants or animals and consisting of long-chain fatty acid ester. It is typically made by chemically reacting lipids such as animal fat, tallow, soybean oil, or some other vegetable oil with an alcohol, producing a methyl, ethyl, or propyl ester. So, using palm oil as biodiesel-based production. Palm oil is the most potential vegetable oil which can be used as raw material to manufacture biodiesel, and on the other hand, the usage of crude palm oil considered to be the most wanted palm oil products for its cheap price and readiness for downstream processing. Palm oil also contains various phytonutrients, fats, and ester that can be separated out prior to biodiesel production. Palm oil presents a high amount of palmity and oily acid that have been well known as the most suitable sources for biodiesel production. This is the piping and instrumentation diagram for manufacturing of biodiesel from palm oil. Process description. Firstly, to manufacture biodiesel, each The palm oil undergoes refining process. The refining process consists of digestion process. The fruit are heated and the exocarp is digested in the digester. Mesocarp is separate from endocarp and kernel. By pressing, mesocarp is pressed to release crude palm oil in the extraction of pressing machine. Kernel is separate from the endocarp before crude palm oil is extracted. Clarification and purification. Insoluble content is removed during clarification. And lastly, refining and fractionation. Crude palm oil is processed into refined, bleached, and deodorized palm oil. Fractionation separate the liquid part, olein, from the solid part, stearin. Secondly, it undergoes transesterification process. The transesterification process is a reversible reaction and carried out by mixing the reactant, fatty acid, alcohol, and catalyst. A strong base or a strong acid can be used as a catalyst. Methanol and sodium metallite are added to the palm oil in the mixer. The mixture rests for 1 to 2 hours until the fatty acid, methyl ester, and glycerol naturally separate. The temperature needs to be between 65 to 75 degrees Celsius. The third step is the washing. The more traditional wet washing method is widely used to remove excess contaminant and leftover production chemicals from biodiesel. In this process, a fine water mist is sprayed over the fuel. Fatty acid, methyl ester is then washed down to remove unwanted compound that may compromise its quality. The water need to be heated between 65 to 75 degrees Celsius and pH between 4 to 6. The fourth step is drying. Heating the wet biodiesel with electric heat is very efficient and the most common way of adding heat. Heating with stirring and a good movement of fresh air over the biodiesel. In order to improve its quality, the water is removed from it by heating up to 130 degrees Celsius for 10 minutes. And the last process is filtration. Lastly, the biodiesel undergoes mechanical filtration process to remove particles and molecules of impurity, generating a final product of exceptional quality. The equipment used in the main process is pump to increase the pressure of palm oil into the mixer and throughout the process. Second is mixer. The palm oil and alcohol been mixed. Thirdly is compressor. The compressor compresses the mixture of palm oil and alcohol before heating. The fourth equipment is heater. Heater increase the temperature of the mixture before reaction, and reactor is used to further react the mixture after heating to maximize the quality of the product. And lastly, the oil will be transported to separator, the fluid settling the product by separating fatty acid, methyl ester, and glycerol. Fatty acid, methyl ester will be on top and glycerol at the bottom. And that's all from me for palm oil product used in non-food industry. Thank you.